Which of the following contain delocalized electrons? So delocalized electrons are electrons that are, well, not local. That means that they are electrons that are shared between more than one atom. So that means that we can draw some valid resonance structures that involve moving those electrons around. It is handy to know some patterns that we typically see when looking for resonance structures. So one thing that we can see is an allylic lone pair. So allylic is the position that is adjacent to an alkene. So this, for example, would be an allylic lone pair where you can have some resonance. Like an allylic lone pair, you could also have resonance if we had an allylic cation. So if you had a pi bond with a cation next door, then this time it would be the pi bond that would shift. And we could see that positive charge being shared between the two carbon atoms. Another pattern we might see is if we had a lone pair adjacent to a cation. So if we had something like this, then we could draw a bond, an arrow moving these electrons in to form a double bond. And finally, another pattern that we should recognize is if we have a pi bond that is between two atoms that have different electronegativities. So a common example of something like this would be a carbonyl, right, where we have a carbon-oxygen double bond. And so you could move those electrons from the pi bond onto that more electronegative oxygen atom. So now that we've looked at these four general patterns, let's take a look at the structures that we have. So in structure 1, we have the pattern of an allylic cation. And so we can move these electrons towards the cation. So we definitely have some delocalized electrons here. If we look at structure 2, we have again a pi bond, and on an adjacent atom we have a lone pair. So we have an allylic lone pair here. And we can draw resonance where we push this lone pair in. And finally, if we look at the third structure, we have an alkene, we have a lone pair. It might be tempted to classify this as an allylic lone pair, but that nitrogen atom is too far away. And this carbon atom here that lies in between the nitrogen and the pi bond is sp3 hybridized. We cannot push any electrons towards that. So there are not any resonance structures that we can draw with the third structure. So structure 1 and structure 2 are the ones that have the delocalized electrons.